Okay, lesson 27 is Law of Exponents. What's our objective class? Get ready?
Laws of Exponents.
Law of Exponents. So today you're going to learn how to multiply and divide exponents, or bases with exponents. We've already learned a little bit about exponents as far as x to some exponent really means you times x by itself an n number of times. So whatever n is, you would keep on multiplying x by itself. So with that in mind as a little reminder, let's take 3 cases of exponents. We've got x to the 5th times x cubed. If the base is the same, there's a rule of how, I'm just going to make it bigger, be a little easier to see, of how to figure out what the exponent is. So I'm going to multiply x to the 5th times x cubed. Let's say I can't remember the rule. Eventually you'll memorize it, but if I can't remember, let's figure it out. X to the 5th means x times x times x times x times x. X cubed means x times x times x. So if we were to figure out how many x's that is, we would just count the total number of x's. There's 5 here, 6, 7, 8. So a total of 8. Do you see the relationship here and here? So we would add the exponents to get our total exponent number. So 5 plus 3. So if you multiply and the bases are the same, add the exponents. What do we do to the exponents? Get ready?
Add them.
Add them. All right, what if we divide and the base is the same, 3, but we have a 5 here and a 3 here? The rule is, okay, before I tell you the rule, let's say we can't remember the rule. Let's figure it out. Okay, when I was younger than this, I couldn't really remember, so I figured it out. 3 times 3 times 3 times 3 times 3. That's 3 to the 5th. 3 cubed would be 3 times 3 times 3. Well, to simplify, 3 over 3, or 3 divided by 3, is 1. 3 over 3 is 1. 3 over 3 is 1. I'm left with the 1 on the bottom. On the top, I have how many 3's left? Get ready? 2. 2. So I really have 3 squared. Do you see a relationship here to there?
Yeah.
Yes, so the exponents, the rule, when you divide bases of the same number, the exponents get subtracted. What do I do to the exponents? Get ready?
Subtract them.
We subtract them. All right, so, and it's always the top one minus the bottom one. The numerator, exponent minus the denominator. And then our last case, what if I have an exponent to an exponent? This is a power to a power. So let's just break it down. See, I can't remember the law. Let's figure it out. X cubed squared means x cubed times x cubed, right? 2 times. So then I think, okay, well, wait a minute. I had that law just before up there that said if the bases are the same and I'm multiplying between the two, what do I do to the exponents? Think. Get ready?
Multiply. Add.
Sorry, this is kind of new for you guys. We add these two, okay, but say, it's Mrs. Boone, this is kind of new. I don't have it memorized yet. Let's figure it out. This means x times x times x times. This means x times x times x, right? 3 of them here, 3 of them here. How many total do I have? 1, 2, 3, 4, 5, 6. I have x to the 6th. Okay? Look at this relationship. What do you see here and here? What do you see, Lucas?
Oh, and I have a question. So, because of the parentheses, wouldn't you do x to the power of 3, and then you would do, so let's just say that's 9, and then you would do 9 squared, right? Because it's in a parenthesis, so you do the parentheses first, and then you would do the squared.
The 9, that would only be a 9 if I had, how would I get a 9 right there?
Well, I'm just doing theoretically, because you'd have to do the inside of the parentheses
Yes.
first, and then do the squared, so it wouldn't be x to the 6, it would be like,
Some
so
number, but we can't do, if we don't know the number, we can't calculate that number yet. So it's a good question. So always keep your order of operations in mind. Is he saying, don't we do parentheses first? Yes, but we can't really do them because we don't know what x is.
yeah, but, so you wouldn't be able to add the 2 to the 3, because let's say the x equals 3, then it would be 3 times 3 would be 9 times 3 is 27, and then you do 27 squared instead of.
Okay? So you're saying, what if
3
that's
to
a
the
3?
6.
So that would be 27. And then we'll square that. Right? So yes, you have to do the inside first and then square it.
So it
But
could be a different
still,
thing.
wouldn't this be the same as 27 times 27? Isn't that what I did here? I just haven't figured it out yet, because I can't.
But how'd you get a 3 down there and then there's a 2 up there?
Oh, because there's 2 of them. Because I square, this 2 means I do this twice.
Okay.
Make sense? Okay, good. Questions are great. So if you have questions, that means you're really thinking and wondering. All right, so what's our relationship between 3, 2, and 6? The relationship is multiply. If you have a power to a power, you multiply the exponents. What do we do to the exponents? Get ready?
Multiply.
Multiply. So we're going to give you the general property table right here and make sure we're really clear on it. When we multiply bases, you add the exponents. What do we do to the exponents? Get ready?
Add.
Add. A plus B. When you divide, you subtract the exponents. Top minus the bottom. We'll go A minus B. What do we do to our exponents? Get ready? Subtract or A minus B. Subtract or A minus B. When we have a power to a power, we multiply our exponents. What do we do to our exponents? Get ready?
Multiply.
Multiply. All right, so some of you, I can tell this is brand new, so we're going to practice a few problems so that you get comfortable with it. All right, simplify using the law of exponents. Simplify means solve. I want to get a number answer. I want to get the simplest form possible. So 3 cubed times 3 squared. PEMDAS says do parentheses first, there are none. It says exponents next. So I'm going to do the exponent before multiplying. Do your exponent. So 3 cubed means 3, sorry. That's the long way to do it. Can't we use our new property now? Yeah. Let's use our property. The property says if the base is the same, I can do what to the exponents? Think. Get ready? Add. Thank you. I'm glad you're listening. 3 to the 5th power. This is a shorter way to do it. That's why we love these properties. We don't have to reinvent the wheel every time. 3 to the 5th means 3 times 3 times 3 times 3 times 3. So here's some students who've had trouble with today. They're like, I don't know how to do that. They get a little lost. So group them into pairs. There's a 9, there's a 9, and there's a leftover 3. Work vertically. 9 times 9 is 81, times 1 more 3. 3 times 1 is 3, 3 times 8 is 24, 243. That's the simplified answer because it's the most simple way to write it. Solved for a final answer. If it said, what exponent would you have, then you don't have to simplify it. You just show me the exponent. Hey, 2 to the 5th times, or divided by, 2 squared. Let's use, instead of solving top and solving the bottom and dividing, let's try our shortcut, our cool property. So, what do I do here and here? Josh.
Subtract.
Subtract. Tell me what to write.
The minus sign?
Yeah. Oh, right here?
Oh.
Is it, what is subtract? 2 minus 5 or 5 minus 2 or what do I write?
Well, I thought it was a 3. I don't have my glasses. It's 3.
He says, I'm just going to skip to the 3 because I can see 5 minus 2 is 3. Let's calculate 2 times 2 times 2. 2 times 2 is 4, times another 2 is 2, and then 4 times 2 is 8. There's our simplified answer. Okay, next one, power to a power. The rule is, think, am I adding, multiplying, or subtracting? Okay. Get ready?
Multiply.
Multiply. So, what do I write? Weston.
5 times 2, that'd be 10, so 3 to the 10th power.
Awesome. 3 to the 10th power. Now that one would take a little bit to figure out, but up here, didn't we have 3 to the 5th power? And we said it was 243. Okay. Could I maybe split this up and go, well, this is 3. There's 5 of them. There's 5 more. Isn't these 5 243? And isn't these 5 243? So at least that gives me a bump start to solve it faster, and then I just need to times those 2 numbers and solve it. Or in your calculator, you type 3, type this button, and a 10. Or in your calculator, you can do 3, y to the x, and hit a 10. And that'll take your base and raise it to this exponent. So that's another way. It's a big number. It's like 49,000 or something. Lucas.
Do you ever divide exponents? Or no?
Do you ever divide exponents? You mean not the base, just the exponent?
Yeah, just the exponent. Could you multiply how?
Like, for example, 3 to the 1/2 power? Yes. You won't hit that till next year. We don't do it at all here. All right, so simplify 2 cubed plus 2 to the first plus 2 to the 0. PEMDAS, parentheses, there are none. Exponents, there are some. We do exponents next. 2 cubed, we've already done is 8. 2 to the 1 power, that's just 2. 2 to the 0 power, this will be brand new. Anything to the 0 power is 1.
1.
What is anything to the 0? Get ready?
1.
1. So then we add these two, that's 10. We add the 1, we get 11. Someone said, why is it 1? That makes no sense at all, Mrs. Boone. Let's work it out. For example, 2 to the 4th means 2 times 2 times 2 times 2. 2 cubed means 2 times 2 times 2. 2 squared means 2 times 2. 2 to the 1 means 2. 2 to the 0 means 1. Okay, why is that? They're all 2's and then we have a 1. Well, let's see. To go from here to here, it looks like we had to divide a 2 out. From here to here, we had to divide by 2. From here to here, we divided out a 2. Did we also divide out a 2 to get to there?
Yes.
Yeah, that's why. 2 divided by 2 is 1. Okay. Last part of our lesson is, what if we had a base 10? These are so cool and easy because 10s are easy to work with. Base stays the same, add the exponents, we get 14. Base stays the same, subtract the exponents, we get 2. Base stays the same, multiply the exponents, we get 20. And it says, write it as a power of 10. That's a power of 10. 10 to the 14th power. 10 squared, 10 to the 20th. Any questions? Jacob?
Can you write out 10 to the 20th, please?
I don't want to. If you want to, you can. Okay, we're on 178. Please read the directions. Take it 20 seconds down to break.